Thanks for joining in. And I'm glad you all are here at this early morning time, even though the half of the Vegas is already like in midnight or sleeping. So thank you for waking up early and walking into our session. So why are we here? We are here to talk about our technical experiences with one of our strategic customer, how we help them adopt hybrid cloud using IBM software and VMware SDDC stack on the top of it, and help them scale from a small size to a noticeable environment size. We will share our pains, our happiness, our experiences during the entire journey.
Yeah, we're not going to make you guys go through this. This is day 3. If you haven't seen the disclaimer slide yet, you're not the crowd that's here at 8 a.m. So you guys have seen this before. We're not going to waste time on this.
So move on?
Let's move on. Well, we got to go the other way.
Okay. A quick introduction. I'm Ahmad Ebro. I'm a staff solution architect within VMware Customer Success Organization and currently focused around supporting our key CISO partner Accenture, helping them build private and hybrid clouds using VMware solutions. Living a happy life with a family of 4 and just thrilled working on technology.
Good morning, almost said afternoon, East Coast time. And first time speaker jitters here. So, excuse me, my name is Tim Jabut. I'm a VMware Staff Solutions Architect. In my current role, I'm actually the embedded solutions architect for IBM on all of their VMware and IBM cloud solutions. Keeps me really busy, but when I'm not busy, I'm back home in Raleigh with my beautiful wife of 18 years and my 2 teenage children that keep me busy the rest of the time with football and soccer. If you guys want to follow me in anything that we're doing, you can reach me on Twitter at @TimJabut, or you can reach out to me via email, tjabut@vmware.com. So let's set the stage. What we're looking to do here. Ahmed?
Sure. I thought maybe you will go through all the bullets, okay. So, as I mentioned, we are going to share the technical experiences of our customer engagement. It's going to be a high-level technical overview of that engagement, our methodology, the solution design kind of things. We will also walk through the challenges, the methodology which we followed to make it successful for our customer. And then we will have some lesson learned from our engagement, some bad, some good.
All right, so he told you what it is. I'm going to tell you what it's not. We're not sales reps. This is not a sales pitch. This is not a hybrid cloud design lesson, so to speak. This is a retrospective of, it's a true-to-life inspired design. There's no real names, and I also want to preface the fact that this is an approach. I think all of us in here as architects and engineers will agree that there's no one right way to do anything. This is the approach that we took with the requirements at hand with the partners involved. And we would ask, we're hoping to leave time at the end for questions, but we'd ask that you hold them until the end if you would.
Sure, and we will be hanging around after the session if you want to go further detail on the technical side of the technical details of the solution.
Ahmed will. IBM's got me booked out the rest of the day.
I will move around, sure. So, who was our customer? It was a large-scale, US-based national healthcare with millions of policyholders and billions of annual revenue. So, why they were so critical about their IT resiliency and agility? Because the kind of the services which they offer to their policyholder, their customers, are so critical that they needed to make sure their IT is resilient, it's agile, and it can serve their growing need. So agility, scalability, and speed was kind of the key requirement from the solution.
One other important point is I think we can all agree here that the state of US healthcare is highly expensive. So one of their guiding principles was they were looking at ways to offer lower costs. Well, in order to offer lower costs for their subscribers, that means that they have to lower their internal costs. So they were really looking at shifting from an OpEx to, or excuse me, a CapEx to an OpEx model, and that's one of the inspirations for this design.
Thanks. So let's look at their pre-hybrid cloud state. So they were virtualized 90%, a needed vSphere environment, based out of vBlock infrastructure underneath. And one of the interesting things with their ongoing vBlock environment was, like, first it was going to be old enough, it was aging, and it was already stressed, and it needed so they needed to decide for adding more capacity, or they needed, or there's any other path. So we'll go through how we went through the next steps on their decisions. They had an upcoming refresh cycle, which means millions of investment on those newly purchased hardwares. And I think all these challenges drove them towards the hybrid cloud. And I think their vBlocks were, even though those were converged infrastructure, but those were still they had their life cycle process was taking enough time for them to really support their services need.
Yeah, I think let me add on there for just a quick second. So basically the customer, while their vBlocks were rock solid, and we're not going to get into any competitive bashing here at all. vBlocks are great, but I think anybody who's used them knows that they're about as polar opposite as a cloud model as you'll get. The agility that they were looking to achieve, they just couldn't do it in a cost-effective model with the vBlocks. They also had basically expressed to us that they no longer wanted to invest in ongoing vBlock infrastructure. They were going to let their vBlocks run their current life, and they may have some use for additional in the future, but they really wanted to branch out into cloud. So they came to us with approximately 2.5 years left in the usable life of their amortization cycle on their vBlocks, which is why we have a 24-month time slot in the title.
Yep. So this is more of a high-level business slide I can quickly walk through. Means we already covered most of the points, the agility, moving from CapEx to lower APEX things. So I think I would just quickly move on. Quick thing means they wanted to simplify the hardware and software. Automation was one of their key strategies. They had VRA, VRO in place, and they wanted to leverage it into their new environment as well. And finally, means I think replacing vBlocks with a hybrid cloud kind of a model would also help them reduce their footprint and carbon targets or the goals. Sure. So I think, again, this is a fast-forward slide. But they wanted no vendor lock-in, better control, scale, and speed. Quick catch-up on their use cases.
It was supposed to be a hidden slide,
Yeah.
the joys of live presenting.
So it means all those standard cloud use cases like bursting, DR, scale-up, these were their key use cases, nothing. So let's quickly walk through the Bluemix architecture. Means IBM Bluemix is a framework which sits on the top of their bare metal services and leverage VMware SDDC stack on the top of it. VMware bring in network virtualization through NSX, which enables the DR capability, network expansion to multiple sites, and a lot of other value-added services like load balance and netting and the firewalling. They also have vSAN as one of the offering for, if there's a customer who wants to move towards a path of storage virtualization, they offer vSAN, and then they have endurance storage as well.
So I want to stop right there for a quick second and point out that's a very important consideration in this project. This project started well over a year ago. We didn't have all the current advances that we have in vSAN today, so we were working with an older BOM. That version that was available didn't support a critical feature that's required, a US requirement for healthcare, and that's data encryption at rest. Because of that, we actually had to peel back the vSAN virtualization layer. If we were rebuilding this today, we could do it, but at that time, we weren't able to satisfy that, and we had to utilize IBM's endurance storage behind the scenes instead.
So one of the key capability which SoftLayer offers is having controls in customer's hand. Means customer would have control, and they can even choose between keeping the control on-prem and still leverage the cloud expandability capabilities. And on the top of it, the automation piece means this environment is highly driven with automation and orchestration tools as well. And since it's kind of like a containerized environment, means if a customer wants to bring in their cloud managed platform to manage their workloads within this environment, in our case, I think our customer also wanted to manage their environment from their on-prem automation platform. So automation is a key layer which sits on the top of this environment, and making it more agile and efficient.
Skip the next one.
This is, I'm not sure if it's very readable or not, but means it's a multi-layer architecture. Means it shows like how they have organized or modularized the software environment with physical layer, virtual layer, and then there's a management layer, and there are some services layer as well. So they have like some common services for which are shared across all the tenants or customers, and then each customer would have their own infrastructure stack.
Yep.
So what was the point means for our customer to move to the cloud? Means they were on vBlock, they had all those challenges. So I think the first step was to really expose our customer towards the capability of the hybrid cloud. This was their first experience, and this is the kind of the model which we started with, having like some kind of initial experience for our customer, how they can really seamless migration from their on-prem to the cloud environment, what are the different capabilities, as well as how they can move workloads between different geographical locations within the cloud as well. Again, it was more about seamless expandability from on-prem to the cloud.
Yeah, this is as IBM likes to phrase this all the time, this is a dip their toes in model. I mean, customers that they see that are some of the largest corporations in the United States and the world, these companies employ tens of thousands, hundreds of thousands of VMs scattered throughout footprints. But even the biggest companies, they dip their toes in 25, 50 VMs at a time until they get comfortable with it. This is how this project started. Just very simple. Probably all of us in this room have done this before.
Sure. And we'll go into deeper details in the upcoming slides. Tim would cover how these different components are actually functioning in the whole solution. So IBM has almost like 40 plus data centers. For this customer, they were based out of California, and they were actually literally in the same city, I would say literally sharing the same premises as well for their on-prem colo environment as well. So luckily it was like a natural match for them to select the San Jose data center for IBM, and they were having literally like less than 5 millisecond latency for their network. So they were literally on the same network, same physical network. That was the kind of the performance. But there was a strategic, yeah, go ahead.
Yeah, I was going to say, then there's a secondary requirement as well, which is why we see 2 data centers here. Again, being healthcare, they had to be able to attest that they could pull off DR exercises, once, twice a year, but they have a strict out-of-region requirement. So obviously the first data center was chosen due to its close proximity to where the initial source vCenter was for ingestion. We needed to fulfill the out-of-region requirements. We looked on the map, and lo and behold, IBM's premier data center, the headquarters of all what used to be SoftLayer, is based in Dallas. They've got very robust network connectivity between them. We're seeing the average is sub 35 millisecond latency between the two, sustained for months. It's incredible, and it's very high bandwidth.
Yeah, means I don't want to turn this into a sales discussion, but
no.
I think one of the value which they are getting from using SoftLayer backbone is that IBM doesn't charge anything, right, to their customer for the private
Yeah, now we're getting salesy.
So that's why I was.
We'll leave that to the sales folks.
Yeah, so means it's a highly reliable, high performance private network that our customers can leverage for their DR and other key use cases.
All right, so here's where we get into the meat of what my first year and my last 2 years has been. IBM came to us and said, listen, VMware, we love what you're doing with these VVDs, these VMware validated designs, but we need to shrink it down. VVDs are great. We need to cloudify it. So we came up with a small collapsed cluster footprint. Everything starts with a host. So we had to go with, we worked with SoftLayer on vetting out a very particular bomb of materials, that's great. So what we came up with was we had a single host when we first started this project. It was a very robust host with two 12-core processors, physical processors, hyper-threading, half a terabyte of RAM, and we have two dedicated boot disks for the OS itself. Each host also has 4 10 gig NICs for connectivity, 2 public, 2 private. What this gives us is it's a host that was then passed on to VMware to be validated, that it passed muster and was certified and compliant across all of our products that make up the SCDC stack. So now we had a host, and we knew we wanted to get to this small footprint. And again, the footprint being VVD based, and being that, as he said, the standard architecture was inclusive of vSAN, because full SCDC stack, we need to include that. Now we need to find out what this thing can hold. So vSAN, 4 nodes for production. We needed a way of gauging that. Talked to IBM, we're like, yeah, what are you guys seeing for average workloads across all your customers? And they were actually able to pull some metrics. Maybe they asked Watson, I don't know. And they said, across the board, our average workload is 2 vCPUs, 8 gigs of RAM, and 70 gigs of storage. So they see by and large. So I said, okay. So we took that, we plugged it into our cluster calculations. We did some very conservative overcommitment ratios. We all know that we can push virtual to physical process pretty hard. We only went with a 6-to-1 ratio. RAM, 1.3 to 1. These are very conservative numbers. We didn't want to work it too hard. We wanted to make it realistic. When all was said and done, we were able to come up with a fully HA 4-node building block, call it a Lego, call it what you will, that'll support up to 200 VMs.
Sure. So before we move on, I think one of the key difference for us was when we were building with this collapsed design, we went out of our common best practices. Like for the NSX, you need to have like separate clusters for the management at edge. And we went on building this small size 4-node cluster, which was having all the management and compute workloads. First of all, it was a POC environment. When we went into the actual production environment, we followed all the kind of the right practices which we could carry on in terms of the separation of the functions between the management and the compute. for the POC, we leveraged that collapsed cluster design. I think the way we managed the resources within the cluster was making sure we have still the resources available to the resource pools, and making sure whatever the network connectivity is required and we had all the network components also inside the same cluster.
So you remember what we started with, right? The goal of the POC, 200 VMs, achieved. Now we can all go home. We're done. I'm done. So now what happens though? Well,
this changed again?
This changed again.
Yeah.
Oh, God, go back.
Okay.
It's supposed to be a guy beating his head off his desk. You know, it's like that feeling of euphoria when you achieved your POC goal, only to have the sales rep call you up and say, "It's great, customer loves it, exceeded expectations." Now they want to go from that 200 to 40,000. Oh, and you only have 24 months to do it. Go. Uh-oh. Weren't prepared for that.
Yeah, so imagine the girl smiling, it's actually a guy banging head. So
Speaker
it's
services.
different with this picture, yeah.
Changing approaches. Now we have a new edict. We have a deadline. It's got 24 months. I could think of no better way than to just do very simple linear straight line math to do this. I said, all right, 40,000 VMs, 24 months, simple math. I don't have to go too difficult. It's roughly 1,700 VMs every month for the next 24 months. We know that each of our building blocks supports roughly 200 VMs. So that's roughly 9 building blocks every month. That's 36 hosts. Every month we've got to add into this overall environment. Let's break that down even more. You're not going to want to work your operational folks to death on weekends and nights over the next 2 years. So let's be nice to them and say, yeah, we're only going to swing workloads during the days, 5 days a week, 4 weeks in a month. That means 85 VMs every single working day over the next 2 years has to move. That's all. It's not daunting. We can do this. Here's where I pulled the rug out from under you. I told you 40,000 workloads. I never said they were all production. All right, you guys are all probably sitting there and you're here because you're like, 40,000 workloads. How's he doing that? We know we've got virtual maximums. You can't get over 30,000 VMs. You're right. We have a different mantra with this one now. Moving 40,000 VMs, one of the new guiding principles was, as I told you at the beginning, that they want to get off those V blocks. They want to get off those V blocks, but they have some very high tier 0 systems of record that by corporate policy are never allowed to move off their data center. So what they asked us to do is it possible that you can build a Bluemix type cluster on-prem? And we can move those workloads there. And we can also, we're like, sure, and we'll also use it as a staging area. That'll be our jumping off point. So approximately up to 5% of their total workload real estate was these tier 0 cluster and very high availability applications that need to stay up running all the time. So we plan for up to 2,000 VMs. We're certainly not going to, that's 40 hosts. We're not going to build that out on day one, but we're going to add to it. They have a very verbose test dev QA environment. 12,000 VMs. Production, 13,000. And then all of us know, because every good admin, if you have 13,000 production VMs, you got 13,000 VR VMs, right? Everybody does that, right? All right. Quick math, if I'm right, that's 40,000 VMs. Next.
Sure.
Here's where we break down our tiering. Again, I said that there was roughly 5,000 or 5% of the VMs. That's about 2,000 VMs. Those we need to attest for zero data loss, which has some ramifications. We need to be able to do synchronous replication. These are the guiding principles that kind of drove us down the fact that this had to maintain on-prem. We weren't going to stretch this properly because we can't put synchronous storage into the cloud very easily. Then we've got production high tier, which is our tier 1 through 3 workloads. We have about 4,000 of those, 20%. These guys have RTOs of 1 and 8 hours, and they are critical to the business keeping the lights on. I mean, these things need to be up, so we need to ensure that there's automated failover and recoverability for these. Because of that requirement, we know right off the get-go we need to have replication. One of the downfalls of endurance storage is, because of the way it has to be abstracted, it does not have a storage replication agent for SRM. So we had to get around that. We used vSphere replication. Worked out great because we only had up to about 4,000 VMs. So, vSphere replication, 2,000 max per virtual center. Our low tier secondary applications still might be necessary for the business, but 1 day and 3 days, RPO, RTO. Secondary at best, and they didn't want to incur additional costs with SRM and all of the additional virtual centers support such a high load. So what we did was, instead we just said, why don't we just mirror endurance between the 2 data centers? So we mirrored the 2 data centers, and we had a scripted recovery model by which we could just power them on. They were already pre-registered, and we'd power on the VMs. Non-prod, absolutely no BCDR at all. We're like, right, really? Non-prod's production for somebody. We said, no, in this model, we don't care. It's, production is production, non-prod, if in the event of a disaster, it goes away.
I will let you talking, but I think we have older version. I have attached the USB, so if you can quickly open it up.
I don't know.
Yeah, because I think it's older version.
All this fancy computer learning.
Because I'm seeing like the changes are not there, but here's the changes. So let's use this one.
Bear with me, folks. Give me 15 seconds.
I think it's better than going with the wrong slides. You can open it from here. Yeah. Let me do it for you. Okay. Okay.
There. All right. Here's the meat and potatoes. This is what we had to deliver. So, as you see, we have our legacy vBlock data center. We have our Bluemix on-prem data center, which is really physically located with the other, hence the red dashed line box. They're grouped together, but they're 2 separate SSOs, completely non-federated. The on-prem data center is actually part of a hybrid cloud SSO domain, which extends to both San Jose and Dallas. That is a single NSX domain with cross vCenter capabilities. Workloads. We need to be able to get workloads into the environment. Now we have non-federated SSO. But what we do have is the ability to leverage the APIs. The APIs will allow us to vMotion those in. We may have to pull a few additional tricks to swing networks, but all's not lost. I mean, we do have flexibility with what we ended up actually doing for the high tier workloads, the tier 0 that we had to attest for and try to keep them up as long as possible. We ended up cross-mounting the LUNs between the Bluemix on-prem into their on-prem. We just cross-mounted those LUNs, and we were then able to vMotion the workloads over, which then required a storage vMotion to relocate their storage. At that point, they were sitting on the Bluemix on-prem cluster. We had to take a slight outage, maybe 15, 20 seconds while we swung the networks just to swing the default gateways, and that was up and running. That was able to be accomplished very rapidly due to the cross-connect of the storage, or the cross-mount of the storage, and the fact that it was never going to move off of that data center. The other tiers of workloads, we had a little issue with those. It's not really an issue, it's just we had to plan for an outage. There was no other way around it. In order to get them from that single on-prem environment into a cloud, into a model that would support cross vCenter vMotion, we had to leverage universal objects. We couldn't just vMotion from on-prem into the cloud model, hit a universal object, and expect routing to occur. So what we did was we worked with them, we came up with a plan, said, all right, what we're gonna do is we're gonna swing these a VLAN at a time. So we would basically group all the VMs in a move group, in a particular VLAN. We would schedule an outage window, we would vMotion them over. At that point, they could still talk to each other, but they couldn't talk east-west back to the original cluster, which is why we moved the entire VLAN at a time. Then we created a LIF, repointed, and away we went. At that point, they were good to go.
Sure. I would add a couple of things from the networking point of view. Since it was same location, it was very easy for them to cross-connect between the vBlock environment to the newly built on-prem environment. So that's how they taken care of the physical network piece. If you notice, there's like a cross vCenter NSX domain for the right side of the picture. That shows means it's all falling under one big NSX domain. And the left side was on the legacy physical network or legacy VLANs. So Tim discussed in detail about the migration and everything. During that transition, we also needed to make sure that there is necessary network services available as well during the transition when a workload is actually moving from a vBlock legacy environment to the new environment. So what we did, we set up a parallel on-prem north-facing internet ESGs with the right set of firewall policies and load balancing, whatever the network topology that application was leveraging. And we made sure during that transition, once that entire VLAN is moved, we detach it, and then all the traffic would go from the new hybrid cloud environment on-prem. You want to add anything else?
No, I mean, at that point, once we're on those universal networks, at that point, we do have the ability to migrate into any of those, either the Bluemix on-prem, which is really, for these VMs, it's a staging area. So they literally can move from there to the other two data centers, San Jose being primary and Dallas being DR. But yeah, we can freely move throughout the environment at that point in time across the robust backbone.
Sure. I would say one of the most complicated process was actually understanding their network and understanding how the different tiers are kind of networked and what kind of network services they need so that we can make sure that new environment also carries that on.
So I told you in the beginning that they wanted to get off the CapEx model and go more to an OpEx model. So now all of a sudden we're talking about all these different tiers of workloads, and there's an awful lot of potential for waste of hosts. So what we did was we kind of analyzed their workload and we said, all right, we know we have the ability to replicate from on-prem into the Bluemix cloud environment. So once we get to the Bluemix on-prem, which is on the left, the on-prem DC, we can go to the Bluemix San Jose cloud DC. We have the ability to replicate in there. Who wants to manually move 2,000 VMs serially when we can just leverage replication? So that worked out in our favor. Lo and behold, we were capped at 2,000 VMs for vSphere replication. Well, that's all we sized the environment for. Production, we know we have 4,000 production VMs, high-tier production VMs that we had to be able to attest that we could move them. So we broke them up into 2,000 group units and assigned each to a vCenter with the appropriate number. Basically, we maxed out the number of vSphere appliances. And we paired them up with a pair of DR vCenters and vSphere replication servers in Dallas. We've already said that we have about 9,000 prod low-tier workloads, and those 9,000 workloads, we're just going to use vSphere, endurance mirroring. So we didn't have any considerations at all around that, about how we were going to get them from point A to point B. That just works, and that's fine. But when I looked at it, I said, well, that's 9,000 VMs. I've got 12,000 non-prod VMs. Do I really want to build out and have all that excess capacity for the prod low tier, which is just going to be handled with mirroring? So what we did instead was we said, let's take 9,000 of those non-prod workloads and put them in Dallas. And we'll reuse the same hardware. So basically what we're doing is we run 9,000 non-prod workloads active in Dallas. We run the remaining 3,000 VMs in San Jose, in the San Jose cluster. And we basically have a scripted procedure, because at this point, all of those 18,000 VMs that encompass prod and non-prod are registered to the virtual centers. So in the event that a disaster is declared, we let the endurance storage finish its replication or its mirroring. We run the scripts, shuts down all non-prod workloads, and the prod low-tier workloads, which are already registered, power up. And away we go. There's no waste that way, because that's 9,000, yeah, I mean, that's about 180, 200 hosts that would just be sitting there on the sidelines. Kind of defeated our rule number one, don't break the bank. And yeah, I mean, we've already established non-prod has no BCDR components, so we could get away with pulling a model like this.
Sure. And this slide is showing the compute vCenters, and we'll go through the overall design, which also have added components.
So we kind of touched on this, how we migrate workloads to the cloud. This was, I mean, it's really a slide that's explaining exactly what I've talked to you about. But so when we wanted to migrate to the cloud, we had two options. We could migrate from the vBlock environment via a vMotion and a storage vMotion, because we had to relocate both compute and storage. Once we placed it on the staging environment, we had VMs that need to be replicated to the cloud, so not the tier 0 stuff. So, but all of our other tiers, and even non-prod, if we were moving them into the cloud, they could jump in and be replicated. And from that point, we could vMotion and move them anywhere that they needed to in the 3 cloud-based data centers. As we procure hosts over time, we can utilize the fact that we can move these VMs anywhere in the environment to essentially rebalance the workloads to ensure that we keep our asset utilization and planning properly constrained. And yeah, additionally, Site Recovery Manager, we use that to orchestrate and automate our production high-tier environments to migrate them to the cloud. We also have the ability of leveraging them. We didn't do it, but we would have the ability to do that, to move from the on-prem Bluemix data center into their cloud environment. It didn't end up needing to be necessary, but it was a consideration. I basically already told you this slide. Once the workloads are in that cross vCenter domain, we have the ability to just migrate them to any of the 3 data centers. Our endurance storage is presented to both. The universal objects extend to all 3. We really didn't utilize it in that methodology per se, because we wanted to keep Dallas as DR with the exception of non-prod. But we did rebalance workloads across the 3 vCenters that were in San Jose.
Yeah, it was all about efficiently leveraging the resources.
Yeah, I mean, it was definitely all about, decreasing that CapEx and getting your OpEx at a peak performance.
Yeah. Okay, so now we have the component level breakdown for all 3 sites. We'll start from the very left of the slide. So that is the on-prem environment. Like Tim mentioned, it's kind of like playing like dual purpose. One was the staging, the other was also keeping the tier 0 workloads. So on-prem has a management cluster, and it carries all the management workloads for the environment. But if you notice, there are two vCenters on-prem. So the top one is to actually manage those four node management cluster to make sure we have the separation of management function, since it's a highly scalable environment, healthcare, critical application and services, tier 0, all these things were, all these parameters driven us towards making sure that management component is highly available in the event of the failure. So we decided we will keep we will have like one vCenter only for the management pieces. From the networking side, we are using the VDS, the regular VDSs for that piece. But we are using NSX for the compute part of the environment. And that's where you would see the second vCenter. This is meant to be managing the compute workloads or compute clusters. And it has one-to-one relation with the NSX manager for the compute. If we come a little bit below the management cluster, now we can see like we have like two clusters, means we know it was like 2,000 workload. It can scale if it's needed, but in its current design with our current requirements, two compute clusters were kind of like meeting the requirements. So the first one, we used it in a collapsed manner where we put the NSX controllers and edge appliances into this NSX edge appliances, which are kind of which are the north-south router and firewall component of the NSX. So we put those components under this first compute cluster, and then we have like replication appliances. Tim already covered that massive number of workloads that need replication from this on-prem environment to the cloud environment. So we have those replication appliances distributed across the clusters.
I think the important thing to notice here is that when we started the POC, we started with a very constrained collapsed cluster model, right? Because it was all about containing costs. We're still all about containing costs, but as we start scaling this environment, we need to go more towards what the VVD is, what the VMware validated designs are. They give us a methodology by which a patching or an upgrade event isn't potentially going to affect your production virtual centers. And that's where the concept of dedicated management clusters, and I don't want to call it a manager of managers, but I mean, you have your dedicated management clusters by which your other clusters will reside and your other virtual centers will reside. So as this shifted from a small POC to a large scale environment, we basically had to shift back to, we need to adopt these best practices.
Sure. And we were having like local storage from IBM for the on-prem environment. And like he said, we actually even had forced our VVD guys to certify our collapsed cluster design as well for this customer. That was another story. For the San Jose data center, what we have is we are replicating the same management design. Means we have again one vCenter dedicated for managing this 4-node management cluster. And then we have NSX secondary manager. So as we know, Cross vCenter supports up to 8 NSX sites or NSX managers. So what we have done here is we have like put the primary right on-prem because customer wanted to keep the control in their hands. That was very important for them. Means even though they were moving into the hybrid cloud, but they were still not fully trusting all their critical things. So that's where the solution requirement was that, okay, we will keep all the critical and management and the control things. So NSX primary is over there, and then we have the secondary NSX managers for San Jose and Dallas, and I think like we needed the replication appliances. I haven't really populated it with all the components, but in short, like all the controller NSX pieces beside the manager sits on the compute cluster. NSX manager is the only piece which is sitting on the management side. And I think the bottom piece just shows like how the endurance is, and endurance storage is leveraged to migrate the.
It's mirrored.
Yeah, to mirror the.
Nothing to see here, folks.
Okay, so this is a little bit populated slide, but I think what it just shows is the network piece, because that is another critical component of the design, that the expandability of network between the on-prem and soft layer. So this is like the standard approach when they are connecting customers on premises. They have like direct link. They offer like a couple of options for the WAN connectivity. But what I wanted to show was the highly redundant components lying on the underlay, which is the bottom piece of this network. Means if you can see all the routers and other networking components are highly redundant. If we talk about the host level, means each host we made sure there's like redundant 10 gig interfaces for the high availability. And we were even using like NIC teaming to further, like add the performance from the networking side. If we were using VXLAN, now we had like 20 gig for the private network for that piece.
And if the IBM police are here, don't chastise me. For our use case, SoftLayer, IBM Cloud, Bluemix, IaaS, they're all one and the same. Oops.
It's common, right? Means they started with SoftLayer and now it's Bluemix. So here we are talking about the logical connectivity. So I think what this slide or this design demonstrates is that, okay, customer can extend their logical network from Bluemix on-prem, and they would have still like same IP subnet, same network for their workloads. So we are kind of using the NSX cross vCenter active design. Software underlay helped us extend it and like play with the network topologies to provide all the networking services to our workloads, regardless of whether they are on-prem or they are in the cloud environment. This is more of a deeper look inside the networking design. Means what it shows is like we have the SRM on the San Jose side, and we have Dallas for the DR side, and how NSX is leveraging integration between the SRM, NSX to make or to offer a seamless migration of workloads from San Jose to Dallas. So the previous slide was about on-prem to cloud, and now we are talking about from one cloud side to the other cloud side. So again, means we have all the key components of NSX here, like we have the logical switches, the active workloads are on the active side, which is the San Jose, and we have the UDLR. I didn't put the animation, but means technically like it's just like when the entire site goes down or individual component goes down, we have like component level recovery as well as we have site level recovery for this environment. So if site A goes down, we will have site B taken over seamlessly.
Execution. So I didn't want to go into too much detail on, we're starting to wrap up here. This is, as you move up the pyramid in this slide, we're, as one of my colleagues likes to call it, this is his maturity model. He turns the pyramid upside down. I went against the grain and kept it a regular pyramid. But when we started, we started with a very basic premise, right? We had a POC to build for 200 VMs. Mission accomplished. Changed, pivoted, went to 40,000 VMs. But we basically adopted the same constructs, the same building block approach that we've spent the past year or so working on. We leveraged known entities with NSX and IBM Endurance. That gave us a stable platform, gives us a stable base to build on. Then as we started adopting and migrating those workloads, and we started to have to plan for rapid, massive scale, we had to figure out how we were going to protect it. And due to constraints, as we've talked about, vSphere replication and SRM, best in class, best what we had. The top slide is something that I would be remiss if I didn't even mention automation. We've talked about some homegrown scripts that we're going to shut down non-prod and turn up prod, and we have the ability to execute and leverage other scripts that would handle the API calls to do the vMotioning. All of this stuff was done with teams within the both IBM and the company that shall remain nameless. The next phase in their growth process is leveraging VRA and VRO. It wasn't part of the migration project, but this is future state. Lessons learned.
Yeah.
So I can tell you, having lived and breathed it for over a year, that I say lack of overall vision, but I think it's lack of overall sharing of vision, both from the customer right down to the cloud seller, right down to the implementation and architecture teams. Had we have been given the full scope of this project in the beginning, we probably would have designed our POC to mimic and look more like what our end state ended up being. Lack of complete requirements. This is one I'm sure everybody in this room gets on any project. I mean,
it keeps changing, right?
Right. So some of these things should just be boilerplate lessons learned, because until we start fixing them at. But yeah, I mean, how many times have you been in an engagement and you don't get the complete requirements, and all of a sudden, everything goes upside down?
Yeah, I'm seeing environments which are built on one design for the NSX, and now customer wants to break the whole piece and start it's if it's cross VC, now we need standalone domains, or it's the other way around, right? It means the requirements are kind of changing some on the fly things as well.
So the customer's requirements put some serious constraints on our design. As we said, we spent a lot of time as VMware working with IBM on the overall solution, and that solution that we spent time fostering, that became their standard reference architecture, it's also the basis for their version of vCloud Foundation. I mean, this building block is leveraged in many layers within IBM. But due to the customer's requirements, healthcare, data encryption at rest, we talked about that one. vSAN had to be pulled out. I guess it's a testament to how sound the architecture was that we were able to peel that out without it being a major fiasco. But I mean, it caused some architectural challenges. And this one cannot be overlooked. No, we got one more. Yeah, stable common services.
Yeah, means I have lived through this pain of networks are so much built into the DNA of a customer, right? Means it's really, I think one of the key consideration for moving towards a private or public or hybrid cloud is actually how to get rid of all the constraints from the networking side. And on the top, we want the same experience. We want the same IP addresses. We want the same network services, same topologies. We don't want our applications to be changed at all. So that's where the bring your own IP, lesson learned comes in. That if you go with a greenfield environment for a test dev, it's pretty straightforward. But when you are moving your production workloads into a newly built environment, you need the same kind of network, environment or feel. So you want to carry on all the kind of the basic networking things. So bring your own IP if that is one of the customer requirement. Just make sure you do the necessary planning piece. I think it's just the planning, the components, technology, everything is there. So I think with every large scale deployment, We just go through a proper networking planning for bring your own IP use case, and we are all set.
I think with that, we're a wrap. We've got maybe 5 minutes if there's any Q&A.
Yeah, and again, it's 9 a.m. in the morning.
And if there's not, we thank you guys for getting up so early, though. I will say, just to catch these guys, and then I'll grab you. Thank you guys very much for waking up at 8 a.m. to come in and spend your morning with us. And if you wouldn't mind filling out your survey, it's the only way that we get graded on these things.
So we still have like few minutes for the question as well, so feel free to. Okay, we have the guy, right?
Yes, sir.
Great presentation.
Yeah, we're not done yet.
By the way, awesome. Quick question. So your building blocks, your 4-node building blocks.
Yep.
If you put 8 of those in a 32-node cluster running via DRS at 5, you're going to have a lot of gravy on the top, extra capacity in the cluster. Can you tell me your cluster sizes, and did you just write off the gravy as, hey, we just know it's going to perform better than our POC, or can you go into that a little bit?
Well, I mean, so for instance, we knew we were constrained by 32 hosts in a cluster, and the reason why we were constrained by 32 hosts in the cluster was because the version of NSX that we were using. Yeah. So we, again, this was a year ago, so we were at 624. We basically, until we started crafting the dedicated management clusters, because it didn't start out that way. It started out as collapsed clusters, and then once we would hit a certain saturation size, once we would hit, maybe we'd hit 20 hosts in a cluster, we would then say, okay, it's time to start carving out a dedicated management cluster, and then we'd suck them up underneath. And at that point, we would just create separate compute clusters and try to keep them balanced and grow them organically.
So what was your final size on those average on those clusters? Were they 20?
Good God.
It was different between.
Yeah, it was depending on the environments. Some environments we had, I want to say we had 180 hosts in San Jose. You catch me off guard, and I had a slide for this too. But when they did speaker services, I mean, overall there was hundreds of hosts involved in this project across the 3 data centers.
Sure.
We know that there was 40 just in the on-prem data center. We're probably looking at about 120 for each, so maybe roughly 360 sounds about right. And then I think it was 180 in the DR data center. And
did you calculate that out for the client, as far as that gravy of taking those building blocks and saying, okay, here's where our POC is. We've got so much more capacity because. No, we did. Okay.
Should we? Probably, but remember this was a joint engagement with IBM GTS services as well. So we can't overstep our bounds in what we have latitude to do. They're paid basically to go and monitor and size the environment and work on the metrics for that. We help them create something that was repeatable, that was very easy and modular for them to scale. But again, like I said, we worked with a reference VM workload sizing just to come up with basic numbers, knowing that you're going to have to monitor your environment and know what you need. You may only get 100 VMs in that cluster, but overall, over the course of that cluster, it balances out that we were generally seeing 200 VMs per cluster.
Definitely worth getting up for.
Thank you.
Morning.
Morning.
So looking over your design and the different designs that you were talking about amongst companies, it appears that the building block for going from an on-premise cloud or an on-premise situation to a hybrid cloud model has to be NSX or some software-defined networking. Do you see that as a true statement or something that you have to have in order to move from your on-prem location to a hybrid cloud situation?
Well, if we were out right now, I'd basically say, I'd be like, hold my beer and give me 2 weeks and come back and ask me that question. We have some announcements that'll be coming out in Barcelona, so stick around. I'm not at liberty to discuss them right now.
That's fine. We don't have software-defined networking in our organization because we're small to medium size. We don't have the funding for that at the moment. We're trying to piecemeal that VCF foundation, and we're not there yet.
So I'll let Abba take this, because so basically the question is you don't have NSX on-prem.
Exactly. I think what he says, and I would repeat, that do we really need software-defined networking to expand into the hybrid cloud, right? And the answer is it makes your life a lot easier.
Okay.
If you have single network management experience, all from, like management control, data plane, from one single solution area. Means if you'll go with the other path, I think it would be harder for you to manage as well. SDN is enabler for the hybrid cloud, I would say, for seamless migration from on-prem to what are the other ways for you to move the workloads if there was no NSX, and means then you need to do all the manual reconfiguration of the network.
Makes it a lot easier.
Yeah, so that's the goal.
It is always 100% a requirement on software to have it. It's the only way that they can address an overlay underlay environment.
And that's IBM's.
You're going to find that with most cloud providers, though, because I mean they have the concept of an underlay and an overlay in order to be able to give the customer their own unique space. So, but yes, I will say that with every single IBM cloud SDDC delivered model, it always includes NSX.
Yeah. The only thing is I'm just stepping away a little bit from like, okay, this is the mandatory requirement, but I think this is kind of going close to be like, means if you look at the VMC kind of a thing, or IBM and all these major clouds that we are working with, you would see all of them are adopting the software-defined network.
And we'd like to. It's just that dollar figure we can't have.
Yeah.
Thanks, guys.
Thank you.
Thank you very much.